Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2014, longest subsequence repeated k times. This question has been asked in Meta recently 3 times in the last 6 months, and it is marked as hard just because of couple of constraints. Otherwise it is based on backtracking concept, utilizing some other techniques as well, greedy, counting, string. Let's have a look on the problem statement. You are given a string s of length n and an integer k. So here we are given a string s of length n size length string is given to us, and an k integer is also given. Our task is to find the longest subsequence repeated k times in the string. Let's understand what they are asking. A subsequence is a string that can be derived from another string by deleting some or no character without changing the order. Just a definition of subsequence. Subsequence, let's say if I just delete this e and the rest of the string is a subsequence. So you can delete couple of characters, either 0, 1, 2, 3 or n characters. Then the remaining string in order is subsequence. A subsequence is repeated k times if in the string s, sequence into k is a subsequence of s. Okay, so they are saying, let's say I am picking a subsequence of this string s. I have picked that subsequence. If I repeat that subsequence k times, k is the second integer given to us, then this string, let's say that subsequence is le. So this le, if I k is equal to 2, so le, this le is also a subsequence of this string. So subsequence into k times, like appended k times, is also a subsequence of given string. If this is the case, then this subsequence is repeated k times. Then we can say that this subsequence is repeated k times in the string s. They have also given an example. BBA is repeated 2 times in the string, this string. Let me zoom in this example. BA, BA, BC, BA. So this is the string given to us, and the value of k is 2. So here if we have to see, we have to get a sequence such that if I just append this sequence by the same sequence, this string itself is a subsequence of this string. So if I just have a look, BBA, this is available here, BBA. So this BBA subsequence from this portion, and BBA is a subsequence from this portion, and it is repeated 2 times. So this is the answer here. Longest subsequence repeated k times. Okay, this is the problem so far. And in the end, return the longest subsequence repeated k times in the string s. Okay, if there are multiple subsequences, let's say there are multiple options. If I have a look on this example, here in this string s, if you try to have a look, let 2 times. Why? Because k is 2. So after appending 2 times, this whole itself is a subsequence of this. But if I just have a look on this ete, this is also a subsequence of this. So maximum subsequence which is repeated k times is of length 3 here. But in this case, if there are multiple options, choose the one which is lexicographically largest. Which one is lexicographically largest? LET is the one. So LET will become the answer of this example. LET is something we have to return. If there is no such subsequence, then return an empty string. Okay, so this is the problem statement, and if I just give you a brief again. First of all, we are given a string s. String s is given to us of character n characters. String s is given to us of length n, and along with this k is also given. So what we have to do is we have to figure out a subsequence out of the string such that that subsequence is multiplied by k times is also a subsequence of s. So this is something we have to find. Let's say if k is equal to 2, then this sequence should be repeated k time, two times. If k is equal to 3, this subsequence I have to use 3 times, and after appending it 3 times, whatever string it is forming, it should also be a subsequence of given string. And if there are multiple options, return the lexicographically largest. If let's say the maximum length is 3, but at maximum length 3 we have 2 options, then return the lexicographically largest one. So this is our problem statement here. And now how do we do it? Let's also have a look on the constraints. Let me copy it. Now in the constraints they are saying that what is n? N is string.length. This is we already know. And they are saying that this value of n will go greater than equal to n, and this k also less than 2000. So this value of n and k can vary in this range. Okay, that's fine. But what is this third condition? N is less than k into 8 greater than equal to 2. Greater than equal to 2 is already given in the above condition, but this is something new. N is less than k into 8. And apart from that, S is going to contain lowercase English letters. And lowercase English letter we already know goes from A to Z. Only 26 in number. Now let's try to check on this condition. N is less than k into 8. And what is this k here? K means whatever is the subsequence that is going to be our answer should be repeated k times. If I just flip the order, k into 8 should be less than n. Not less than. K into 8 should be greater than n. K into 8 greater than n. If I just consider the worst case, in the worst case, this value of n is largest. Let's see what will be the value of k in that case. Let's say n is 2000 and k into 8 is greater than 2000. So if I just move this a here, 8 here, so it will be something like this: 8 to the 16, 8 for the 40, 8 5 the 40, 250. So k is greater than 250. So this is the condition coming in the worst case. And if it is greater than 250, so what is the minimum value of k? K is greater than equal to 251. And now, as per the problem statement, they are saying that there is a subsequence which is multiplied k times is also a subsequence of s. If this sequence into k is also a subsequence of s, definitely it is also less than n. So length of sequence into k is less than n. Is less than n. And what is the worst case range for n? 2000 into k. Sequence into k is less than 2000. If I just move this k here, so what is the minimum value of k? Minimum value of k is 251. 251 as we already derived. So length of this sequence will be less than 2000 divided by 251. Let's say it was 250. In that case it would be 8, but it is 251, so definitely less than 8. So it is something 7.9. So it shows that the sequence length, that as per this problem statement, sequence into k is also a subsequence of n, and as per the given constraints, this sequence will be of length less than equal to 7. Why? It is less than 7.9. There is nothing like we can take character 0.9 portion of any character. No, it should be integer. So sequence length is equal to less than equal to 9. So this is the sequence length that we are going to get as per our worst case conditions. So here this is the equation which is more important, that this sequence, let's say in this case let, this will always be less than equal to n as per the constraints. If it is always less than equal to n and we have characters which are 26 in number, so definitely we can try out all possibility. One more thing we can consider, let's say this sequence into k is sequence of s. If this subsequence into k is also subsequence of s, let's say this subsequence is abc. It means in the given s, this abc is coming k times. So definitely this character will also be coming at least k times. So whatever character who is going to come into this sequence will belong to character with frequency greater than equal to k. Character with frequency greater than equal to k, character from S which is having frequency greater than equal to k. Okay, so this is also something we have to pick, like, and these characters we have to form all the subsequence of length whatever is given to us, and definitely it is less than 7. Now let's come to the problem statement again. Let's LeetCode with k equal to 2. Let's LeetCode is our string and with k is equal to 2. So here this is the string and we are going to pick all the characters with frequency of this character is greater than equal to k. So that is like a prerequisite, because it is the only case if I can use the character in my sequence. If k is equal to 2, it is something like this: sequence, subsequence into subsequence. So it is coming 2 times. So definitely if we are going to pick any character to form this sequence, that should be having frequency greater than equal to k, at least equal to k. So here if I try to capture frequency of everything, capture frequency of every character of S. You guys already know how do we capture the frequency of every single character, and these character will go from small a to small c. It means a 26 size array is sufficient for us. 0 is mapped to a and 25 is mapped to c. It means we are going to use custom hash table to capture the frequency of every single character. And the second step that we have to do is extract all character with frequency of that character greater than equal to k, because these character will behave like a candidate to form subsequence. So let's say that is like candidates. List of character candidates. So I have extracted all the characters. So in this case, let's say L is coming 2 times, E is coming 4 times, and T is coming 2 times, and S is coming 1 time, C is coming 1 time, O is coming 1 time, T is coming 1 time. So from this table to form the sequence, what are all the characters that I can pick whose frequency is greater than equal to 4k? L I can pick, E I can pick, T. What is this? T I can pick. So these 3 characters I can pick, and we can form all the subsequence out of these characters. So far it is clear that from this string S, first of all we have to capture the frequencies and from all of those frequency, the frequency is greater than equal to k, we have to capture those character. And using these characters, let's say these character is L, E and T. Using these character we can form a subsequence, and that subsequence we can also check that maximum length, string dot length divided by k. Maximum length should not cross this length. Just try to form the subsequence from out of these characters, and also check that whether this subsequence is not crossing this length. So here, yeah, that's all we have to do. Now we have to generate all subsequences. Generate all subsequence out of candidates, candidate characters. Generate all subsequence out of candidate characters. And how do we generate the subsequences? Do we have to keep track of this? Let's just blindly generate it, because we already discussed that the sequence length will always be less than equal to 7. So just go with the brute force. Brute force means generating all possibilities. So whatever is the character, let's say LET, we are having LET, we are having, we can generate all the possible combinations, considering that we have an infinite supply of these characters. But one more thing we also need to consider, that let's say we have found out the subsequence, and see, when we are generating all the subsequences, when we are going to capture it, we will capture it if that sequence into k is also a subsequence of string. Sequence into k, this we can figure out definitely, and it is a subsequence of s. How do we check? 2 pointers and iteration. Using 2 pointers, simple 2 pointer iteration, we can figure out whether this sequence into k, or maybe whether this sequence is coming in this string k times. Whether this sequence is coming in the string k times, then capture the subsequence. Okay, this subsequence we have captured, and let's say we have got the subsequence of length 3, and again we got another subsequence of length 3. How we are going to compare? We are going to compare lexicographically. But when we are generating every single thing, why not we just generate in lexicographically order? Why? Because if we are going to pick Z first, then Y, then definitely we are generating lexicographically larger subsequence first. So capture the frequency from all the valid one. From all the valid one, form the list of candidates in the reverse order. Bigger character first. So from Z to A. If frequency of the character is greater than equal to k, then capture. So this loop you can use. I am just giving a brief idea of every single aspect that we have to take care of. So this is going to be our ultimate approach. This is the string given to us, and this is the k, and we have to find out the longest k repeated subsequence which is lexicographically largest. So we found out that these characters are going to form the subsequence, and definitely the subsequence length is less than equal to 7. So just go ahead with the brute force over generating all the subsequence. And to check whether the subsequence is valid subsequence or not, we can utilize 2 pointers. Whether this subsequence is coming k times into this S. So this is our approach. Here if you have a look on the code, first of all I have captured the frequency of every single character from S, and after that I have captured every single character with frequency greater than equal to k in the sorted order from larger character to smaller character, so that I don't have to sort the candidates, because I am going to pick the candidates from bigger character to smaller character in my backtracking. So after that, this is the maximum length I can have for my subsequence, and this length subsequence I will just generate every single subsequence randomly. So for that I'm using recursion. Every time pick a candidate from the candidate and then append it to the backtracking and then delete it. So it's like a recursive solution, exploring or generating all combinations using these candidates. If it is crossing the length, just directly return. If it is a valid length, then try to see if it is a repeated subsequence and compare it with the already captured one. If it is a better one, then just capture it and move ahead. So this is repeated subsequence utility function, and this function is checking whether this s is containing word k times. So iterate over this s and check for the word. Whenever the character is coming matching with the word, increment it, and if we have captured word completely k number of times, then return true. So this is something k number time we have captured it. So it's just like two-pointer approach. And here if we just try to run over sample test cases, it is working fine, but if I just submit it, you might get TLE because of this DFS. We are passing 126 test cases out of 313. Why? This is because we are using DFS approach. As the branches are so high in number, these characters can go like here. As we are capturing characters, every single character is going to create a new branch, and there are going to be so many branches, and if there are so many branches, there are going to be so many repeated subsequences. So the DFS is not going to work here. So let's see how we can optimize it further. Here we found out that DFS is going to give us TLE, time limit exceeded. And why DFS is giving us TLE? Because when we are doing DFS, our answer is at 3 for this certain example. Let's LeetCode. Our answer is LET. But even after 3 length answer, DFS is going to still explore every single possibility till length 7. Because our sequence length can go till 7. So DFS will keep on going, and when it is going deeper inside the recursion tree, we are going to have so many possibilities, and if we have so many subsequence, we are getting so many comparisons. So additional logic is there to track the best answer, and too many calls if we are going deeper in the recursive call. So deep dive is something we do in DFS, which is going to give us most of the time invalid answers. So that's why it is giving us TLE. So what is the better comparison here? We can go with BFS. Let's say if we are going with BFS, first of all we are going to explore every single item, every single subsequence of length 1, then every single subsequence of length 2, every single subsequence of length 3, then every single subsequence of length 4. If there is no subsequence, then there is no need to go further, right? So this is the summary why BFS is important, because if we are not able to get better answer at 4 length subsequence, then there is no 5 length subsequence, no need to explore further. And also if we are picking items in the reverse order, let's say item, if we are extracting all characters from Z to A, where is something mentioned? Okay, list of character. When we are picking up these characters from every single character in the list, we are going to pick it from Z to A. And if we are already picking elements from in the reverse order, if I apply these character to my subsequence, which we are maintaining in the form of BFS, then definitely it is guaranteed that it is always be lexicographically largest. Even in DFS, we might have to compare, but in BFS, if we are picking item in lexicographical order, it is always, if I just compare all the length 3 size subsequence, whatever is the first one, let's say first one is LET, so LET is going to be my answer. So to avoid this TLE, just replace your DFS with BFS, and BFS you do with Q. Initially the Q is empty string is there, and after that pick elements from our desired set. Let's say firstly pick L, then pick E, then pick T, then pick L, and so on. Initially capture all the length 1 size subsequence, then length 2 size subsequence, then length 3 size subsequence, and so on. And the last subsequence we have captured will be on the length 3, and length 4 there won't be any subsequence, and then there is no need to go further, so it will save our effort. Let's have a look on the BFS code as well. Here the whole approach is same. Firstly I captured the frequency and then captured the element with frequency greater than equal to k from order Z to A in the reverse order. After that, and this is the utility function, that whether this string can contain this word k times. Word into k is also a subsequence of s. These are also same. And now instead of DFS having redundant operations or having too many sub calls, what I'm doing is for every valid subsequence, let's say current is a current valid subsequence, I'm trying to append candidates like characters into it. If after appending character I'm able to get the better answer, just capture the better answer. If I'm not able to get the better answer, then I will just not move forward, and whatever is the best one, I will just stop there. If the best answer is at length equal to 3, I won't be moving ahead of length equal to 3 cases. So this is the BFS approach, taking a queue, and initially it's empty, and appending character after the current string. Current string is always already empty initially. Then after appending this character, if it is a repeated subsequence, then add it in the queue, so that in the next iteration I will just append every character after it and compare the best answer, and definitely we are going to get the lexicographically largest one first. So this is something, the complete code, and it got submitted successfully. I'm also going to attach it in the description below. You can just have a look, and do let me know in case you have any doubt. Thank you guys, thanks for watching, bye bye.